Hello everybody. In this module we are going to illustrate the survival analysis using the software R. Here survival analysis basically implemented where our response of interest is denoted as death or event. To analyze the event of interest, that is death, we consider the durations of follow up as one of the variable, and another variable that is considered as response variable is death. Survival analysis is broadly applicable in different field, from medical research to engineering research. In sociology it is called event history analysis. In engineering field it is called life table failure analysis, and in medical analysis or medical research it is well known as survival analysis. The term survivals are basically understood generally its focus the distribution of survival times, although there are well known method for estimating unconditional survivals distributions. Most interesting survivals are conditional distributions and the relationship between response variable, that is time, and event. Therefore, the term such as survival are to be understood the graphical representations of survival analysis one area before applying or considering any model building. In this module we are going to check the graphical display for survival data using R and hazard rate estimations using R. In this module we will see the application of R for survival analysis. After the end of this module we will learn how to graphically display survival data using R and how to estimate hazard rate using R. Here we will illustrate our example on acute myelogenous leukemia data published in 1997 by Klein and Moselberger. In this example, variables are time, type, and status. So time is stand for duration of survival, that is time to death or relapse. Type stand for transplantation type, that is 1 stand for allogeneic and 2 stand for autologous, and third variable status coded as 1 for alive of the patients and 0 death or relapse of the patients. Now we will solve the what is the therapeutic effect difference on survival durations. Let's start. Now we will first import the data into R. We will see how to read data into R. Here the variable is time is considered with the observation 0, 3 for first individual's duration of follow-up, second individual duration of follow-up observed with 0.49, like that all individual and last individual observations was with 56.08 months. Now second variable type, as we mentioned earlier, 1 and 2 are given for all observations, and status at the end of the study period, what is the last status of the patient observed, coded as 1 and 0. Now whole variable like time, type, and status assigned in a database called AML through the function called data.frame. Now if we call AML, then we can see the data set like now. If we put attach, and after that we call the library called survival, because in this module we are going to illustrate our example from the function that those functions are in library called survival. now this is our data. Since we have already put the command called attach mll, now we will put here serve feed, that is functions, and within parenthesis serve of time and status, and again we will follow it with type. So what the functions will work here, it will give the type wise different status for the data set name with AML. Now the whole statistics is assigned in a values called leukemia.surv. Now if you call that leukemia.surv and as LTY to define the line of survival curves as 2 is to 3, that is available in R, and after that if we put X lab to labeling the X axis as month and Y lab to labeling the Y axis as survival probability, and after that again we are putting leukemia serve to get the summary statistics. Here to define the legend we are giving maintenance and no maintenance with L2I 2 to 3. That's how the graphs coming. Here this is Kaplan-Meier curves coming for AML study, where months given through x-axis and through y-axis survival probability given, and maintenance and no maintenance are coded. Here you can see the cross marks. These cross marks are basically given for the censored observations. Those patients are not died during the study follow-up. Here we can see that maximum duration of patient observed in no maintenance arm is around 58 months, whereas maximum duration followed for maintenance arm is basically more than 60 months. Here the type again we changed into coded into maintenance and no maintenance. Now we can also define whatever we are called to or are shown to in the graphs by putting legend function. Now coming to again to check the survival statistics, how the functions comes. So if we put the summary leukemia.surv and after that puts times equals to combination of 10, 20 and 60 months. So during 10, 20 and 60 months, how the survival statistics observed for both the arm, that we can see here. This is the R output, and see for type 1 and type 2 that we are coded earlier. For type 1 the time period for 10 months, 20 months and 60 months, it showed that number of people were at risk was 27 at 10 months, number of people were at risk at 20 months were 19, and number of people were at risk at 60 months was only 1, and respectively number of event, that is death or relapse, happened for first 10 months 18, 10 to 20 months 3, and 20 to 60 months 1. The probability of survival that we discuss in Kaplan-Meier estimations, the probability of survivals given that by the fourth column, that is called survival for type 1 patients, and correspondingly below you can also see for type 2 patients. So for first 10 months probability of survival is 0.63, that is 63% alive after 10 months. Again after 20 months 0.56, that 0.2, that is 56.2% were alive after 20 months. It is expected that those who are treated with type 1 after 20 months 56% will be alive. The standard error of these corresponding estimates also given as 0.06 for time period till 10 months, 0.07 for till 20 months and 20 to 60 months with 0.07. The confidence interval, that is 95% confidence interval used here, is also given with 0.51 to 0.78 for first time period with point estimate of survival, that is 0.67. Again for second time period, that is 20 months, probability is 0.57 and corresponding 95% confidence interval is 0.43 to 0.72. Again for 60 months, corresponding probability is 0.532, that is point estimate with standard error 0.07 and 95% confidence interval 0.40 to 0.70. Again if you go down, you will see that for type 2 also the same estimates are given. You have seen that in the survival analysis curve, 60 months till 60 months nobody were there in type 2, so that's why for 60 months we didn't get any estimate for type 2 patients group because nowhere were alive up till 60 months. Now we will use the function called as.data.frame under the summary of functions of leukemia.surv. Now in earlier case we have given time period with 10, 20 and 60. Now we are giving time period with 5, 10, 15, 20, 25 and 30 with variable coded with serve, time and stat. Let's see how the output comes. Here this is the output. Here for 10 months type 1 patients, that is patient were treated with type 1 where survival was 0.63. Again for type 1 till 20 months patient survival probability was 0.56. Again for 30 months it was 0.53 and like that for all variable. For type 1 and type 2, that is data, for all we get the estimates of time. It should be noted that after 50 months nobody were alive in the type 2 groups. That's why in here also we are not getting more estimate after 50 months for type 2 group. Now again here the same function we use as .data.frame to get the estimates from time point 5, 10, 15, 20, 25 and 30. Now we didn't consider the month 50. Now we will get the estimate with for 5 months, that is after 5 months probability of survival was 72% for type 2 patient. And again if you go for second type and row 7, you will find that probability of survival after 5 months was 84% for type 2. See here probability of survival was better in type 2 after 5 months. After 10 months probability of survival was 63% in type 1 whereas it was 68% in type 2. After 15 months probability of survival in type 1 patient group was 56% when it was 59% in type 2. Now see here it's crossing this probability of survival decreasing from 15 to 20 months for type 2, that came down to 43%, whereas it was still seeing 56%, 56.17 especially for type 1. Now for type 2 it's keep on dropping. For 25 months it was 39.39% and for type 1 it was 53.21%. For type 2 again after 30 months it was 39.39%, whereas it was still higher side for type 1, that is 53.21. Now we are only, earlier we have used the function combination of serve and serve feed function. Now we are using to only serve function. Please should note that here in serve you are using the capital S. In generally all function written in R are small syntax, but here in the survival analysis function serve is written on capital S after the URV. Now we are assigning the serve for type 1 and status also 1, and we are asking to fit, and after as a SURV fit for my SURV, and again we are calling it as a my.fit. Now to get the estimate of hazard function, we are calling as log, definitely minus log of my.fit for SURV. So see, we have noticed in what is the reason to check the minus log of survival that we discussed earlier. Now to estimate the hazard rate, we are calling minus log my.fit asterisk serve. To get the cumulative hazard, we have to put combine and within parenthesis capital H dot hat, that is assign third line, and after that tail for 1. Now see how the R output show. R output will give the, if we call the m.serve that we assigned earlier, it will give me what is the time month wise observations, or that is follow up observations of all patients. Now if we call that my.fit that we assign, it will give me the type wise how many patients were at risk, how many patients event occur, and what is the survival and what is the confidence interval of survival estimates. So see, in survival analysis we have noted that all theoretically all patients will die after certain period. Here also we can see at the end of study all patients are more or less dying, and probability of survival keep on decreasing. Now we are calling that h.hat, and h.hat will give me the estimate value for different observations on time, that is 0.02, again 0.04, 0.05, 0.08, 0.1. So you can see here that hazard rate keep on increasing. So one side survival probability keep on decreasing throughout the time period, and here hazard rate keep on increasing throughout the study period, and estimate will come by putting only the function by h dot. In survival analysis, the event of interest is death. In this module we have seen how to plot the survival curves when we are having strata, basically the treatment arm, and treatment arms are denoted 1 or 2, as 1 for cases and 2 for control. Then how to plot the survival curves using R, that we have seen here. Basically the graphical display is one of the important part in survival analysis for further carry the in-depth research. Next we had seen the application of R to obtain the hazard rate estimations. The hazard rate estimations shows the how one arm is better than another arm. The functions using through R has been illustrated in this module.